Hello, welcome to this review. I'm your host, Mr. McMahon. Let's dive right into it. So depending on which class you were in, some of these you might have already done. We're going to try to do whatever's left over on this handout. This, I think, is from when I went through it with my 5A section. So anyway, how do we tackle solving equations? Well, we have to first begin by solving as far as we can. Right? So we would just, divide by 2, and then we're left with sine of x equals radical 3 over 2. And at this point, the main way we do it is we think of the unit circle. And we try to think of, okay, if I have a little unit circle here, like this, what angles on that unit circle have a sine value of radical 3 over 2, right? That's the y-coordinate of that angle. Well, that's going to be this one and that one, right? The height of these points, right, is radical 3 over 2. This one is, the coordinates are -1/2 radical 3 over 2. And over here we have positive 1/2 radical 3 over 2. Right, and so my two answers here, and you can express your answer in degrees or radians, right? You could say this is 60 degrees and 120 degrees, or you could say pi over 3 and 2 pi over 3. But either way, right, we would say that the final answers here are 60 and 120, or you could say pi over 3, 2 pi over 3. So either or, right? Unless I specify, you can choose whether you state your answer in degrees or radians. Now here's something kind of interesting that I didn't really get to in class. If you have your calculators, let's say we're in degree mode. You might realize that I could solve this equation if I take the inverse sine of both sides, right? So on the left side and the right side. Notice because I have inverse sine and regular sine, these cancel, and I have that x equals inverse sine of radical 3 over 2. So I didn't get to this in class. But this is something that you can fall back on. All right, so let's say I'm in degree mode, which I am, and I type in inverse sine of square root of 3 over 2, and I put that into my calculator. It gives me an answer of 60. Right? But your calculator can only give you one answer at a time, and no matter how you do it, it's only going to give you 60. And notice, that's only one of these answers over here. Remember, I'm going to expect to see both answers, right? But at the very least, let's say you're completely lost on a certain problem. You can still do this and at least get maybe some of the points, right? You still have one of the solutions. So anyway, meant to talk about that in class, and I didn't get to. Let's go ahead and go on over here, right? Cosine squared equals 1. Well, to get rid of the squared part, we have to take the square root of both sides. And remember, we have to consider the plus and the minus. Right? So this turns into cosine of x equals plus or minus 1. And also keep in mind, right, we're usually on the interval from 0 to 2 pi. And notice how the 2 pi has a parentheses. The 0 has the bracket, so the 0 is included, right? And so we're not, if 0 is a solution, we're not going to also list 2 pi. We're just going to list 0. And so if you think about the unit circle, right, where does cosine equal positive 1 and where does it equal negative 1? Well, there's only 2 spots. Right. There's this angle line here, and there's this one over here, right? And this is your 0 degree line, this is your 180, or if you prefer radians, this is 0 and pi. Right? So your answers here are x equals 0, 180 degrees, or you could write x equals 0 and pi. Right? Either or is fine. You just want to make sure we are not listing 2 pi, right? Because notice it's not included in the interval. Right? So you list 0 instead. Let me go ahead and go over to this one. I did this one with some of the classes, but not all of them. Right? So again, try to solve as far as you can go. Add 1 to both sides. We have 2 cosine of 3x equals 1. Divide by 2. So we have cosine of 3x equals 1/2. Now, at this point, you kind of stop, right? And imagine you didn't even have this 3x here. Cosine of what equals 1/2, right? So this is where we stop. We look at the unit circle. Where does cosine equal 1/2? Well, there's only 2 spots. There's this angle line, and there's also this one, right? These are the angles where the x-coordinate is exactly 1/2, and this angle over here, this is pi over 3, and this one is your 5 pi over 3. Okay, cool. Or if you prefer degrees, right, 60 degrees and 300 degrees. Now, those are not my answers, because we have this 3 here, right? So what this basically means is that the solutions to this equation are when 3x is equal to pi over 3 and 5 pi over 3. And so if you want the final solutions, you have to get rid of that 3. Well, how do you get rid of it? By dividing by it, right? Right, so the 3's cancel, and we're left with x equals pi over 9 and 5 pi over 9. Right, and you should have 2 solutions there after dividing by 3. And if you did this in degrees, right, it would look very similar. 3x equals 60 and 300. Right, so if you divide both sides by 3, you end up with x equals 20 degrees and 100 degrees. So it can be done in radians or degrees. It looks like we've already done this one. Right, so again, solve as far as you can. And notice how what we did from this step to this step is we took the reciprocal of both sides. Right, because we know that cosecant is 1 over sine of x. So if you flip both sides, the equation is still true, and that gives you this equation over here, which is a lot easier to deal with. We actually already solved that equation over in this problem, right? We already solved that. So let me keep going. Looks like I did this one for section 5A. I think I did it for 8A as well. But again, solve as far as you can. Notice how we take a square root. It looks like I left off this plus minus here, right? And that square root of 3 over 4 turns into square root of 3 over 2. And remember, you get 4 solutions, right? 2 of them come from the number, 2 of them come from the plus and the minus. Right? So just keep that in mind. And those are the angles that satisfy that equation. And then we have this guy. This is a good one to end on. This is a tricky one, right? Notice we have secant here, right? What is secant? Well, that's 1 over cosine, right? If you don't know that, definitely put that on your note card. And if we have secant of 2x, then this is 1 over cosine of 2x. And I know you might want to rationalize this right side, but actually just leave it alone, because notice I could flip both sides here, right? If I take the reciprocal of both sides, I get that cosine of 2x equals radical 3 over 2. Okay, so that's nice. Now, again, just like that other problem with the 3x, right, imagine sort of ignoring this, scratch it out. Cosine of what equals radical 3 over 2? Right, so let me draw a unit circle. line, line. When is cosine equal to radical 3 over 2? Well, it seems like at this 30-degree angle line, and also here, this is your 330-degree angle line. So 30, 330. If you want radians, this would be pi over 6. This would be your 11 pi over 6. All right, so now keep in mind these are not our final answers. All this tells me is that 2x is equal to these angles, right? And so that gives us a simpler equation, right? That 2x is equal to those. I'll just do the degrees version. And so what do I do to get x? I just divide everything by 2. Okay, that's how we get rid of the 2. So the point is, just do the opposite of whatever you see inside of the parentheses there. If you're multiplying by 2, divide your answers by 2, etc. If you're dividing by 4 inside, right, like if, well, let's say we had cosine of x over 4, right? We would multiply by 4. At the end, right? So it's just the opposite of what you do in the parentheses. This one over here would be 165 degrees. Is that right? I don't know. I must be tripping here. Let's see. Yeah, 165 degrees. You could also do the same trick in radians as well. Right? 2x equals pi over 6. And 11 pi over 6. You could just divide everything by 2 here. The 2's cancel. You get x equals pi over 12, right? That's 15 degrees. And then 11 pi over 12, right? So anyway, so this is pretty representative of the kinds of stuff you'll see on the test about solving equations. Let's keep moving forward. Feel free to skip to whatever sections you have the most trouble with. I just want to go fairly quickly so that this video doesn't take too long. All right, so I got these middle ones here. I want to go ahead. The goal is, remember, you want to somehow use one of these 4 formulas, and you want to separate whatever angle you have inside into a sum or a difference of unit circle angles. So like for this one, I might express this one as sine of 60 plus 45, right? Because I know 60 and 45 are on my unit circle and that they add up to 105. Maybe for this other one, right, I express this as, let me do a difference here. Let me do 210 minus, let's say 45, right? That just to shake things up a bit. Let's use a difference equation here. But the point is, if you can do that, and your 2 angles are unit circle angles, we can get the exact value, right? So this is my u, that's my v. Let me go ahead and just plug and chug. All right, so sine of 60 plus 45 is going to be sine of 60 cosine of 45 plus cosine of 60 sine of 45. All right, let's put all this in. Sine of 60 is radical 3 over 2 from the unit circle. Cosine of 45 is radical 2 over 2. Cosine of 60 is 1/2. And sine of 45 is radical 2 over 2. Nice. So it looks like this answer becomes radical 6 over 4 plus radical 2 over 4. Right, don't forget that the denominators there, we have 2 2's. Right, they multiply. And you could leave your answer like this, or you could sort of combine them a little bit, right, and get this. But the point is, this is what I'm looking for. If you give me a decimal, I will not give you full credit. It's too easy to just put it into a calculator and get a decimal. Let me go ahead and use this difference formula, right? So that's this one over here, cosine of u minus v. All right, so this is going to be cosine of 210 times cosine of 45 plus sine of 210 times sine of 45. And you've really got to think about your unit circle values here. 210, just to put it in perspective, if we draw a little unit circle, 210 is around here, right? That's 210. And the coordinates here are negative root 3 over 2 and negative 1/2. So keep that in mind for this problem. So cosine then must be negative root 3 over 2. And then cosine of 45, that's radical 2 over 2. Right? And then plus sine of 210. Okay, so that's going to be negative 1/2. And then sine of 45 is radical 2 over 2. And so what do we end up with? Wow, it looks like negative root 6 over 4 minus root 2 over 4. Again, you can just leave your answer like that. Right? So nice. All right, let's keep going here. Let's see. It looks like I've drawn in red on top of another problem. I was just showing an alternative way to do it. Right, so let me get rid of this here. Get rid of that. So I think in that instance, I was showing how if you have the original, or sorry, your final answer like that, you put it into the calculator and you get a decimal, like 0.26. You could also do this problem using a sum formula, and you should get the same decimal. The answers, the exact values might look different mathematically, but they should give you the same decimal representation. All right. So anyway, let's go ahead and use these formulas. Right. The goal here is, right, you want to somehow rewrite the problem so that it fits this exact template or this exact template. And if you write it in that way, you know that whatever number is here is going to go here. Whatever number is here is going to go there. That's the whole point, right? And usually that number, if you do it right, is going to be a unit circle angle. So we have pi over 12 here. I could rewrite this angle as cosine of pi over 6 over 2, right? And that means that my x is the pi over 6. And so I just put it into the formula, right? The one up here. So this equals 1 plus cosine of pi over 6 over 2 under a square root. Cosine of pi over 6 is going to be radical 3 over 2. And so I just put that in. Now you could definitely simplify that more, but I'm going to allow you guys just to leave it like that. You can box that as your answer. That's fine. Sine of 75. 75 is half of what? Right, so we could write, something over 2 should be the same thing as 75. What is that something? It's got to be, looks like 150, right? If you double 75, you get 150. So take half of 150, you get 75. And so that means the 150 is my x in the formula. And so I'm going to go ahead and use that one. All right, so sine sine of 150 over 2 should be equal to 1 minus cosine of 150 over 2 inside of a square root. And where is 150? Well, that's 30 degrees shy of 180, right? And so if you think about where it is, you should get that 1 cosine of 150. Let me just go ahead and set up the rest of the formula. That cosine of 150 is negative root 3 over 2. Right? So because we have minus minus, that's going to turn into a little plus. Right? And so we end up with 1 plus root 3 over 2 over 2 underneath a square root. All right. So expect to see a decent amount of exact value problems, right? That's one of the main types of problems I can ask you. Other than simplification problems or verifying problems, this is one of the big ones. And then here we have problems about more exact values, but based on a triangle, an actual triangle. So you don't have the angle to work with. All you have is this triangle. And so it looks like we've done sine of 2 theta, cosine of 2 theta, tangent of 2 theta. And we're just now getting into the half angle stuff. So just to refresh on the half angle, in fact, we were just doing that, right? So we're using these formulas. And the cosine of theta is coming from this triangle over here, right? Because cosine is adjacent over hypotenuse, right? So 4 over 5, that's where I'm getting that from. And, if you're plugging in a basic fraction like this, you might as well go ahead and simplify, right? So we turn the 1 into 5 over 5, subtract those two, and we get 1/5. And 1/5 divided by 2 turns into 1/10. And you could leave it like this, or even if you rationalize, you get radical 10 over 10. Right, so either is kind of fine. I know that a lot of these fractions and square rooty things kind of make some people nervous. So anyway, you could leave it as square root of 1/10, like this one if you wanted to. So let's keep going, right? Cosine of pi over 2, or theta over 2, right? That's the other formula. So we have 1 plus cosine of theta over 2 in a square root. Okay, so this is going to be 1 plus 4/5 over 2. Well, if I add those together, this is 5 over 5 plus 4/5 over 2 in a square root. So that's 9 over 5 over 2. Okay, so that's the square root of 9/10. In fact, we could simplify this a little bit. We probably don't want to leave it like this, right? Because the square root of 9 is clearly 3. And we keep the square root on the 10 part. And so from here, yeah, you would definitely want to rationalize for sure. So multiply by square root of 10 over square root of 10. And you end up with 3 square root of 10 over 10. And this would probably be how you'd want to write your answer. Yeah, so make sure you can rationalize if you need to. And then with sine and cosine, we want to go ahead and just take, for tangent, we don't have a formula, but we can just take our answer for sine and divide it by our answer for cosine. And namely, if we have our answer written like this and this, we're going to see a lot of stuff cancel out, right? So I'm going to go ahead and use those forms for the answers. Right? So sine was radical 10 over 10. And we're dividing this by 3 root 10 over 10. And a lot of stuff is going to cancel. It looks like these 10s cancel out. and these square roots of 10s cancel out. The only thing we have left is this 3 on the bottom. Right, so this just turns into 1/3. Wow, that's interesting. Or maybe it's not interesting. I actually don't know. But it's interesting to me. Anyway, so just make sure with tangent, right? If you're going to use this trick of sine divided by cosine, it has to have the same angle for all three of these, right? Same thing over here. Like, I could not, take this sine divided by this cosine to get this tangent, right? That just doesn't work. The angles are different, right? The angles have to be the same for you to use that property of tangent. All right, and let me go down here. In fact, let me go ahead and maybe do this one in a slightly different way. So, notice this middle problem here. So this is the way I did it with my 5a section. What we did was we replaced cosine of 2 theta with this, which seemed like that was the most useful form to put in there. And we had 2 cosine squared and then minus cosine squared. And so this cosine canceled with exactly one of these. So I'm scratching out the 2 there. And I'm left with only 1 cosine squared left. And of course, this minus 1 just goes here. And what we did was we divided through by cosine squared. We're left with 1 minus 1 over cosine squared. And of course, 1 over cosine squared becomes secant squared, right? So we're left with 1 minus secant squared, which that's actually okay if you leave that as your final answer. But you can actually go a little bit further and substitute the secant squared for 1 plus tangent squared, because that's an identity that we know. And when you do that, these 1's cancel out, and this negative distributes to this tangent over here, and we get negative tangent squared. But I actually want to go through this a totally different way that was brought up by my 8th period, which is actually pretty smart. It's actually a lot easier than what I just showed you. So what if instead of substituting this for 2 cosine squared minus 1, what if we actually substituted it for a different version, right? Cosine squared theta minus sine squared theta. And of course, this cosine over here just stays where it is. And over here we have cosine squared theta. Well, notice how this one cancels with this one. And we're left with negative sine squared theta over cos squared theta. Well, what is that? That's equal to negative tangent squared theta. Oh, man, beautiful, right? That took even less work than the last one I showed you. A lot less work. So sometimes you can find shorter ways to do these problems. Over here, it looks like this was supposed to be 2 cosine squared of theta over 2, right? So what we did was we used the identity for the half angle formula for cosine, right, which is this big square root thing, and that whole thing is squared, right? So this squared part and this root cancel out, and we're left with 1 plus cosine over 2, and then these 2's also cancel out, and we're left with 1 plus cosine. In this problem, that's actually really the only way you could do it. I don't know of any other way you could do that problem. And now let's go ahead and go and work on this one. So what can we do here? Well, we notice that we have a product up here, right? 2 times sine squared times cosine. So when I'm dividing by sine, I know that this sine will cancel with one of these sines, right? So instead of sine squared, we just have sine of x now. And now down here, there's just a 1. So really, this whole thing turns into 2 sine of x cosine of x. And that looks very familiar, right? If we scroll up a little bit, that looks a lot like this. Well, we can swap it out, right? We can use this identity, and that's going to make it a lot simpler to deal with, right? So instead of thetas, we have these x's, but this is just going to be sine of 2x. And that's definitely the simplest form for this expression, right? You only have a single function. If you can get things in terms of one function, that's usually the simplest form. I know most of the time we go from this to this, but in this case, it actually makes more sense to go the opposite direction. We're not looking for an exact value here. We're just looking for what's the simplest way to rewrite this expression. So anyway, this was the review part 2. I hope you learned something. And good luck on the test, guys. Make sure your note cards are all in order. You can put all of these identities. I would definitely put these on them. Definitely put these two. Definitely put the double angle identities like these or this. And remember, there's another one for cosine, right? 1 minus 2 sine squared theta. That's another one. And of course, the half angle, we already said you should put those on there too. The product to sum formulas, you will not need to put on your note card. Right? Those were the 8 formulas from handout 5.5 that were on the back side. I didn't even have you guys write them. They were already written on your handout. So don't put those on there. I'll give you the right one that you need for the problem that it pertains to. So just make sure you can simplify. Make sure you can solve for sine, cosine, and tangent for problems like this, right, where you don't know the angle. Make sure you can get exact values using the sum formula or using the half angle formula, and make sure you can solve some equations. If you want to look back, this was section 5.3 for solving equations. So anyway, take care, good luck with your studies, and have a good rest of your week.